I'm eating this banana. I love bananas. Highly recommend bananas. Let's begin with a firm understanding of what a waste to energy plant actually is. A waste to energy plant is a facility that converts municipal or industrial waste into usable energy, typically electricity or heat. Waste is combusted at high temperatures to generate heat, which produces steam that drives turbines for electricity generation. They reduce landfill waste volume by up to 90%, minimize greenhouse gas emissions like methane, and they provide a source of relatively sustainable energy due to the cyclical nature of waste production in modern society. Modern facilities recover metals and other materials both before and after combustion, contributing to resource conservation. Modern waste to energy plants are designed to complement recycling efforts and support a circular economy. Recyclable and hazardous materials are removed before incineration, ensuring only non-recyclable waste is processed for energy recovery. This integration supports material reuse while generating energy from residual waste that would otherwise be landfill. And advanced technologies are being developed to further reduce emissions and increase energy recovery efficiency. Because right now in the United States, we severely lack this infrastructure, and there is a high level of waste. There has been success. In Palm Beach, Florida, they have the Palm Beach Renewable Energy Facility number 2, and it demonstrates that waste to energy facilities can be environmentally responsible and economically viable when properly designed and operated. The construction began in January of 2012, and it was completed in July of 2015. It processes up to 3,000 tons of municipal solid waste daily. This approach significantly reduces greenhouse gas impacts compared to landfilling by avoiding methane generation from decomposing waste, with a net output of about 550 kilowatt hours per ton after internal plant consumption. That's a significant amount of energy, and it can power itself, is the entire point. It's self-powering. The facility costs $672 million, which is negligible compared to the benefits that it'll provide over decades. It's a very important acknowledgement that it has been done successfully, because there are other examples in the US where it hasn't been done successfully. Unfortunately, Chicago has a history of failure when it comes to waste to energy, and there are no active plans to build a waste to energy plant in Illinois, even in 2025. So there were 2 attempts in Chicago, with the Northwest Incinerator, which ran from 1971 to 1996, and Robbins Incinerator from 1997 to 2000. And they represent important lessons. The Northwest Incinerator regularly violated Clean Air Act standards because it didn't have the same emissions controls that we have in modern waste to energy plants. And both of them were located in predominantly low-income minority communities, which raised significant concerns, which fueled community opposition. Modern plants maintain profitability through multiple value streams. And the failure to address legitimate community concerns has led to this negative connotation, which is justifiable. They didn't control the emissions of these plants, yet they still built them. It was a mistake. There are 4 major landfills that Chicago is dependent on. They create significant environmental hazards that could be mitigated by modern waste to energy technology. Decomposing waste releases methane. Rainwater filtering through waste creates leachate. And landfills occupy large areas of land that could otherwise serve as natural habitats or productive spaces. And they disproportionately impact minority and low-income communities. It's a bad solution, and people aren't at fault. This is why technological advancement is so important, because we now know that it is economically viable to implement a solution to the problem of landfill. Cook County regulations prohibit the construction or expansion of landfills within its boundaries. Hauling waste to distant landfills requires substantial fuel consumption and vehicle maintenance, increasing the city's carbon footprint. And it increases the expenses for collection, transfer, and long-distance disposal, which reduce resources available for other city services. The way landfills work, they are unsustainable. They're always filling up. By just digging another landfill, it just perpetuates the unsustainable solution. There is a huge opportunity in Illinois right now to build a waste-to-energy plant. Here's more information about why landfills are terrible. They're a patchwork solution. Undoing the damage caused by landfills is extremely difficult, and it significantly strengthens the case for adopting waste-to-energy technologies. Here's a chart showing the historical versus modern approach. Highly advanced waste-to-energy plants have the potential to be carbon negative, but selective catalytic reduction is what significantly reduces the emission of nitric oxides, which was developed in the 1950s. This chemistry is firmly understood at this point. It's the reason why cars have catalytic converters in them. And you can apply the same technology to a waste-to-energy plant. These technological improvements transform waste-to-energy from a controversial disposal method to a sustainable component of modern waste management. And instead of being detrimental, they can have positive benefits. For a system like this to operate, there is plenty of municipal solid waste. Generating steam from water is not a problem. The waste is incinerated at high temperatures. Modern facilities achieve over 99.9% reduction in traditional pollutants through sophisticated emission control systems. And the high combustion temperature ensures that certain compounds are broken down. You can go even further and capture the carbon dioxide and make the entire system carbon negative using sophisticated carbon capture technologies. It's an emerging technology which is still in development, but it's been proven to be possible. You can convert carbon dioxide gas into solid carbon and diatomic oxygen. They use gallium metals as a catalyst. The solid carbon accumulates as flakes or powder that can be safely stored or used in industrial applications. And a properly designed waste-to-energy plant could employ this technology in the future in a modular way, eventually becoming carbon negative. The energy economics and viability of something like this is clearly proven. Modern waste-to-energy plants can generate approximately 550 kilowatt hours of electricity per ton of municipal solid waste incinerated after internal consumption. After you factor in all of the energy consumed by the plant itself, it still produces 550 kilowatt hours net generated. As far as the carbon capture technology goes, a rough estimate shows that even that, which requires a lot of energy, would be covered by the waste-to-energy plant. Here's a chart showing the energy balance. Here's a material flow table showing the outputs. Depending on how you process the outputs, they can have industrial applications and can be relatively valuable. To further improve the efficiency of the waste-to-energy system, you can use electric garbage trucks for waste collection, and the cost of the energy to power the garbage trucks would be paid for by the amount of mass of waste that they can transfer in a single trip. Using electric trucks would effectively eliminate diesel emissions. And these trucks would have the capability of generating more energy than they consume by delivering municipal solid waste to the waste to energy power plant. And they could be charged on site. in a cyclical nature. So the technology absolutely exists in this regard. I created this flowchart to clearly demonstrate the integrated waste to energy and recycling system. This energy balance estimate is even more conservative than my previous one, which is based on the waste to energy plant in Florida. You don't need the electric garbage trucks. It's just simply an acknowledgement that this system would actually pay for it on top of everything else. The projection that I found would be an 8 to 12 year payback period, but it really depends. Nonetheless, even with this conservative energy estimate, it would still be a massive net profit. This clearly shows the superiority of waste to energy over traditional landfills. It can be done in a clean and environmentally responsible way while simultaneously producing net energy. And it requires significantly less land and reduces the need for landfills significantly. It's important to recognize that landfills themselves have costs associated with them. And when you factor in the external costs are massive. Future implications and the amount of energy it would take to undo the damage we've done with landfills is significant, nearly inconceivable, needing to dig up a landfill and take up all the trash and process it properly. Depending on where you build this waste to energy plant in Illinois, the efficiency increases in many regards. One of the clearest ones being travel time, people just driving from one place to another. And when the landfills in Illinois and Indiana fill up, the solution cannot be simply to just dig more landfills farther away. If the United States is to consider itself to be one of the most developed nations in the world, this is something we should be able to build in the next couple of years, as they did in Florida. Illinois needs a waste to energy power plant, and we should have built one about a decade ago when they built the other one in Florida. But for some reason, we didn't get one and they did. I'm a little bit salty about it. But this system, I hope, has portrayed why it's so effective and efficient. I'm happy to talk about waste to energy because I genuinely believe this is a solution that the state of Illinois needs. It's not about a want or a desire. We're going to need this system. We are relying on unsustainable methods of handling our waste, and there are better ways to do things. And again, people are not at fault. This is not the fault of anyone. We need the direction and the investment. Here are my sources for the video. There are quite a few of them. During the creation of this video, I learned some very interesting things. My energy calculations are estimates. My estimates are based on the Palm Beach Renewable Energy Facility number 2, which was able to attain a net output of 550 kilowatt hours, which I think is fair.